So who took the class yesterday?
Veer Raghavan sir and Vivek Kumar sir. I think
Okay.
started with correlation and regression. There are perfect positive correlation was there, perfect negative correlations were there, and
Oh,
no correlation. Those are the things has been discussed during that Viraghavan sir, and Vivek Kumar has taken us through that DMAC, DMAC, where there is a little bit details. That means FMEA
Fmea.
and means yes, risk priority number, action priority index. So those are the
understand.
things has been discussed, and
So that means,
process FMEA.
so that means the analysis was over, right? Analyze space is over.
Yes.
Okay. So you discussed about the hypothesis testing, and you also discussed about correlation analysis. Now,
Yes.
one of you or even all of you, please try to answer my question. So, what is the purpose of analyze space? How are all these tools, are going to help you? Tell me, what is the purpose of analyze space? What do you want to understand?
Uh, uh, to find out the root cause.
Find out the
Root
root
cause.
cause.
The root cause of a problem.
Very good. To find out the root cause, not just by brainstorming and not just by, the assumption based. You find out the root cause by brainstorming, etc., fishbone diagram, and have a healthy discussion within your team and identify the root causes. And also, you should be able to validate. So, what is validation? Whatever is the claim you are making, like you are claiming that a particular factor is root cause. You should be able to prove it with the evidence of data. See, there are two things. You can simply make a statement. You can also make a statement along with evidence of data. If you make a statement, it is, a claim. Or if you make a statement along with evidence of data, then it is a validated claim. So we just don't want you to find out the root cause. We want you to actually find out the validated root cause. If you say a factor is the root cause, you must have evidence of data. Either you use the existing data or you generate data by performing some experiment. It's according to the scenario. This procedure is known as hypothesis testing. Is that understood by all of you?
Yes, sir.
Yes.
All right. And now when it comes to hypothesis testing, there are two hypotheses. One is null hypothesis, the other one is
Null
alternate.
hypothesis.
Alternate.
So what is your understanding about null?
Null hypothesis is
There is no change. There is no
relation of
change.
equality.
Statement of
Of
equality, there is no change.
uh,
See, if you are in the analyze phase, you are talking about root cause. You can say the factor is root cause. You can also say the factor is not a root cause. If you
yes,
say
sir.
the factor is root cause, your statement is alternate.
Yes, sir.
Because it is critical factor, because it is an influential factor, because the factor has the power to impact your result. Statement of impact, statement of inequality, a statement of influence, a statement of, what to say, criticality. So if I say a factor is a root cause, then it is alternate hypothesis. Then what is null? The factor is not a root cause. You frame a statement conveying the meaning that the factor is not a root cause, then it is null. If you make a statement in a way that it conveys the factor as a root cause, then it is alternate hypothesis.
Alternate.
If you want to say the operating temperature of the boiler is responsible for the poor efficiency, now you have to make a statement. What is your point here? Operating temperature is the root cause for poor efficiency. When I say operating temperature is the root cause for poor efficiency, is it null or alternate?
Alternate?
Alternate.
Yeah, if I say the operating temperature is the root cause for poor efficiency, then it is alternate. I can always say the operating temperature is not the root cause of poor efficiency. That is why the company is currently operating the boiler in that particular range. They think that, that the operating temperature is not influencing the efficiency. That's why they operate in a wider range of operating temperature. So what the company is currently believing is the null. Nothing but the current status quo. The current status quo is null. Normally, we all believe what is being practiced in our workplace. Yes or no? Whatever we are practicing in the shop floor or workplace, we simply believe that it is true. The current belief is the null. The opposite one is alternate. Once you can prove the current practice is wrong, people will start accepting your alternate. Yes or no? Once you prove the current practice is wrong, people will start believing that the alternate is correct. So in null hypothesis, we are trying to prove that null hypothesis is wrong. What is the objective of hypothesis testing? We are trying to prove that null hypothesis is wrong. That is called rejecting the null hypothesis. You must have studied. When you reject a null hypothesis, what does it mean? The experimental finding is significant. Whatever the information you are getting from out of your experiment is believable. You can trust the experiment and make a decision based on the experiment. If you are not able to reject the null, we call it fail to reject the null. You should not use the findings of the experiment. Even though there are some findings, even though there are some information your experiment is conveying, you should not believe in it. Because there is a chance that even the experimental data can mislead you. Yes or no? Whatever, even though you generated a data, there is a little chance that data can mislead you. All of you agree with me? That is known as type 1 error. That is known as type 1 error. The risk of rejecting a true null hypothesis is known as type 1 error. Am I correct? You might have learned yesterday. So what is type 1 error? If you commit a type 1 error, you are actually making an unnecessary change in the organization. Tell me who will like if you make unnecessary change in an organization? Nobody will like, isn't it? So that's why it's a major concern for organization to restrict the type 1 error. Type 1 error should be restricted to less than 5%. In what to say? The Indian law system also says that 100 criminals can escape, but one innocent should not be punished. That is the principle behind our entire system of law. Same thing is applicable. Whether you make a good change or not, you should never make a bad change. Do you understand? Whether you may do a good thing or not, you should never do a bad thing. So you should know that risk of you committing type 1 error. That is getting measured with the help of the tool known as p-value. So in any hypothesis testing, we start with declaring the permissible risk. First step is permissible risk you should declare. Generally, it is 5%. But in industries like healthcare, they even go with a level of significance of 1%. The permissible risk is otherwise known as level of significance alpha. Once the level of significance is fixed as 5%, that means the confidence level expected is 95%. Right? 5 plus 95 is 100. So you can also start with 1% of level of significance. If you start with the level of declaring level of significance as 1%, then the permissible error should be less than 1%. Type 1 error should not, the chance of you committing type 1 error should not be more than 1%. Then only you should use the data. See, we conduct experiment and then we try to believe the findings. But there is a probability with which the experimental data could got generated randomly also. You thought that only the factor has influenced your result. It could have been other way also. Imagine someone writing an exam without making any preparation, without doing any hard work. He simply write the exam by doing inky punky. And once he submit the exam, he is seeing he is getting a pass mark. Now, what does it indicate? How the data is generated? Randomly, or is it because of the hard work of the candidate?
Random.
Random. So
Random.
the random chance generating the data, you must understand that is the risk involved while using a data. Yes or no? Whenever you are using a data, the risk involved is data could have got generated randomly. You might think that it is because of the factor, but it could have been, for reasons other than the factor. So that chance is always there. That is what we measure, in the form of p-value. If that p-value is more than 0.05, under such situation, we don't use any data. Even though we have some data available, even after conducting the experiment, we will not use the findings for decision making. We will simply ignore our experimental finding. So when to ignore our experimental finding? When p-value is more than 0.05. When p-value is less than 0.05, yes, the information contained in the data is significant. You can believe in your experiment. You can take a decision using the data only when p-value is less than 0.05. So this is what we call it rejecting null hypothesis. Rejecting null hypothesis means the current status quo is wrong. The current belief is wrong, right? The current belief is nothing but the null hypothesis. If the null is wrong, then alternate is correct. All of you understand? So start with fixing the level of significance. Then frame your null hypothesis, alternate hypothesis. Then refer data or generate data. Generate data means you conduct experiment and generate data. Then calculate the relevant statistics. If your data is continuous data, you must calculate average. If your data is discrete or attribute data, you must calculate proportion. If you end up making decision using average, then your hypothesis test becomes test of averages. If you make your decision using proportion, then your hypothesis test becomes test of proportion, right? And then the statistics can be converted into an appropriate p-value. Statistics can be converted into an appropriate p-value. And then the p-value decision-making rule is less than 0.05, reject the null. More than 0.05, fail to reject the null. Reject the null means the experimental findings are valid. Use the findings and make a decision and go ahead and make changes in the process. If p-value is more than 0.05, you should be able to simply ignore your experimental findings. Clear, all of you? Even though you have performed the experiment, by putting a lot of effort, still the findings should not be used for any decision making if p-value is more than 0.05. Because p-value is an estimate of type 1 error in your decision. And always the best practice is type 1 error should be less than 5%. But in the event you estimate a type 1 error of more than 5%, it is better to ignore the study and don't make any decision. Simply get along with what is happening right now. Clear, all of you? This is the hypothesis testing. Test of average, test of proportion, all of them are same. All that you need to know is what is the characteristics you are measuring. Is it continuous or discrete? If it is continuous, then it falls under test of average. If it is discrete, then it falls under test of proportion. Suppose imagine you are going to validate a supplier. You are asked to validate a supplier. That means you have to perform some audit and decide whether the supplier is capable of supplying the raw material to you or not. Now, is it a scenario of hypothesis testing? Tell me, is it a scenario of hypothesis testing? Yes, definitely, because you will obviously refer to the data to judge whether the supplier is capable or not. Yes or no? All right.
Yes.
Very good. And moreover, if you are auditing, will you be able to do 100% inspection? Not possible.
No.
That
No.
means it is very evident you are going to perform hypothesis testing. Whenever you take sample and then make decision using the sample, you are performing hypothesis testing. Now tell me, are you coming across such scenario in your current job? So many times you come across, isn't it? So you are unconsciously or unknowingly you are performing hypothesis testing, but hereafter you can do it consciously. And now you are going to audit the supplier. On what basis you will be auditing the supplier? Tell me, how will you understand whether he is capable of supplying you the right raw material? Your raw material should have certain characteristics, yes or no? Tell me a characteristics
Yes.
you will be interested in. What kind of characteristics you might expect in your raw material? Tell me one example.
Food quality. Food quality.
Food quality. So you are buying food material, food product. In the food product, certain requirement. Let us say fat content you have a requirement. Whatever food you are supplying to my organization, the fat content should be less than 15%. That is the requirement, your company's requirement. Now tell me, fat content, is it a continuous data or a discrete data?
Continuous data.
Continuous data because it is measurable. You can send the sample to laboratory and then lab result can tell how much is the fat content. It is measurable. So it comes under test of averages. Whenever data is measurable, data is continuous, it falls under test of averages. You have a reference and the samples taken from the supplier. You will have the average of the samples. Yes or no? Always, you don't just take one sample and decide. You take 10 sample. You take 10 sample and then 10 readings. How will you make a decision? By calculating average. That's why I told you it is coming under test of average. Now, what is the average fat content of the samples taken? This average will be compared against the reference or the standard. What is the standard? Its standard says it should be less than 15%. But what is the sample average says? Is it more than 50? If it coming under more than 15%, you are going to reject the supplier. Yes or no?
But sir, there should be some range, right?
Yeah, there will be some variance. 15 plus or minus some mild, slight variation is always allowed. We will fix a limit. We'll fix a limit and see if you are testing whether the sample average falls on the right side or not. That is your major concern. If it falls on the left side, it is not your concern. But if it falls on the right side, it will be a major concern for you. So your test now becomes a right-tailed test. In certain product, the characteristic should be above certain value. If it falls below, then it becomes a failure. You need to understand which side the failure is happening. If the failure is happening on the right side, it is a right-tailed test. If the failure is happening on the left side, then it is left-tailed test. If the failure can happen both sides, like manufacturing tolerances, dimensional characteristics, if the dimension is above certain value, then also it's a failure. Customer will reject. If it falls below, then also it's a failure. Customer will reject. Then the test will be known as two-tailed test. All right. So you now know how to classify whether the test is right-tailed or left-tailed or two-tailed. We are conducting exam for all of you. What is the test we are performing? We are just checking whether you are able to score above 60 or not. So which side is the failure? Left side or right side?
Left side.
Left side. 60 is the pass mark. Any mark above 60, we are not worried. You can score 90 also, 95 also, not a problem. But if you score 1 mark below 60, then it's a failure. So we conducting exam for you is a left-tailed test. All right. So you should know that. Okay. And then you compare the sample against a standard or a reference. Whenever you compare a sample against standard or reference, the test is known as one sample test. The test is known as one sample test. Sometimes you compare one sample against another sample. That will be known as two sample test. For example, you have two supplier and you want to find out who is the best supplier so that you can cancel the other one. Such a scenario is a two sample test. Suppose you have three supplier or more than three, more than two. Let's say 10 suppliers you have. Suppose a scenario comes where you want to find out the best performing supplier. Now the scenario becomes a multi-sample test. It's not just two. Now you need to know the data type. If the data type is continuous, or the scenario will come under test of average. If data type is discrete, the scenario will fall under test of proportion. Clear? In the example food product, you told me food product. Then I picked up fat content. Fat content is a continuous data. So the test will be, the recommended test will be one sample T test. Yesterday you should have discussed, am I right? One sample T test. Suppose you have two suppliers supplying you the same food product or the same raw material, and you are comparing one against the other, then the test will be two sample T test. Suppose you have 10 suppliers. You want to judge who is best or who is worst. The situation is ANOVA, analysis of variance. All of you understand? If you compare one sample versus a standard, what is the name of the test? One sample T test. One supplier versus another supplier, two sample T test. More than two supplier, ANOVA. But please note the data type of the characteristics must be continuous. There are 14 people right now in the meeting. I want to find out who is the healthiest person in the meeting. That is also a hypothesis testing. Isn't it? After performing hypothesis testing, I will declare so-and-so is the healthiest person among the people in the meeting. But here, how will you measure the health of a person? Can you tell me a metric which can be used as a, metric for to measure your health? Can you tell me a metric?
BMI.
BMI, very good. So BMI, this is called CTQ identification. If I simply measure all your height and compare who is having the maximum height and declare he is the healthiest person, I am making a foolish decision because my CTQ is wrong. Yes or no?
Yes,
You
sir.
have to pick up the right CTQ. BMI, of course, it's maybe can be considered a good indicator. Now tell me, BMI, is it measurable?
Yes.
Yes, it is measurable. What is the formula? It makes use of your height as well as weight, isn't it?
Yes. Yes.
So it has got a proper unit of measurement. Now there are 14 people. All of us will have BMI. And who is going to have the best EMI? Sorry, not EMI, BMI. So the BMI. So now what is the test we are performing? We are performing. What is the name of the test?
No.
ANOVA.
Analysis of variance.
Yeah.
So every scenario, every day, we are actually coming across, the hypothesis testing. You are comparing whether your son is performing better or your daughter is performing. What is the hypothesis testing that is happening there? Two sample test. And your data type decides. If you are looking at test mark, it is test of average. If you are looking at the number of awards won, then it is test of proportion. So every scenario can be brought under test of average or test of proportion, right? So similarly, there is one proportion test, there is two proportion test, there is chi-square test. Suppose if you are a digital marketer, campaign conversion rate is an performance metric, yes or no? Campaign conversion rate, email campaign, SMS campaign, WhatsApp campaign, Facebook campaign, LinkedIn campaign, so many campaigns, isn't it? So campaign conversion rate, tell me conversion rate is a proportion. Am I right? Percentage conversion. If I process 100 leads, 10 of them are converting. So what is my conversion rate? 10%. Now this statistics 10% is known as proportion. Normally your company achieves a conversion rate of 10%. And now you want to offer a service of digital marketing to your company. And you say that you can give a conversion rate better than 10%. But what is the standard? 10% is the standard. And you say that you will give about 10%. Now I want to test whether you really have the capability. Now this is a kind of right tail test. Yes or no? I want to know whether you can give a conversion rate more than 10%. It's a right tailed test. But it is known as one proportion test. Do you understand? If there are two types of campaign, I want to compare one against the other. Two campaign, I want to compare one against the other. Then it is two proportion test. If there are 10 campaigns at a time, I want to find out which is the best campaign for my company. Then it is chi-square test. So how many tests right now I am speaking about? 3 under test of average, 3 under test of proportion. So totally 6 hypothesis testing. 90% of the scenario you will be able to handle by any one of the 6 hypothesis testing. But ultimately, after performing hypothesis testing, you should refer to the p-value. And if the p-value is less than 0.05, you reject the null. If it is more than 0.05, fail to reject the null. Reject the null means you can believe the experiment. You can take actions. You can make changes in the process. More than 0.05, just keep quiet. Don't reveal anything. The risk of your findings going wrong is more than 5%. Under such situation, you should not take that risk. Yes, Samya ma'am, you want to ask something?
Sir, can you please repeat the test of proportion names?
One proportion test, two proportion test, and chi-square test. Similar to one sample T, chi-square. CHI hyphen square. They call it chi-square or chi-square test. On the average side, it is one sample T, two sample T, and ANOVA. On the proportion side, it is one proportion, two proportion, and chi-square. All right?
Yeah.
See, there are many examples we can point out. So, and then you have to get any statement anybody makes. You must get it validated with the data. Whatever the statement communicated, if the same information is coming from your data also, that means the statement is validated. Yes or no? I simply say, we give 100% placement. If data also confirms that we are giving 100% statement, then my 100% placement, then my statement is validated. If I only tell, but data is not supporting that, that means it's an unvalidated information. Please understand. So in hypothesis testing, we are just checking whether the opinion is a fact or not. For the opinion to be accepted as a fact, the p-value should go below 5%. If that is not happening, we will not accept any opinion, any statement as a validated statement. We will not consider that as a fact. If we cannot believe something as a fact, it is better, not taking any action. Yes or no? Okay. So maybe I will just, what is the hypothesis testing yesterday you performed? Did you perform any hypothesis testing using Minitab yesterday? Come on, tell me, did you perform or not?
Yes, sir.
Yes, sir, we
Okay.
did.
Okay, the same example, let us continue. Fat content. What is that reference given by company?
15%.
Yeah, it's a 15%. Everywhere they declared 15% is the fat content in the website, in the product label, wherever. So you wanted to check whether the supplier is really capable of delivering the food product with the fat content of less than 15%. So you took some sample of 10 or 15, and then all the 10 or 15 will have the reading. So in order to have the reading, what will I do is, you remember I have shared an Excel file with all of you, am I right? Did I share the Excel file with all of you?
Yes, one Excel file was
Yeah,
there.
same.
Yes.
Only one Excel file required throughout, all my discussion. So here for the fat content, I have some data. I'm going to use it. So where is that fat content? Cooking oil fat content. You see here, cooking oil problem. So I just copy this and I'm now opening Minitab. You are now seeing my Minitab screen. Oh, sorry. So this is fat content. Look here, your sample, how your sample looks like. You have taken 13 samples. The sample reading goes like this. Now you have to take a call whether can you give the contract to the supplier or not. Now what is our hypothesis testing procedure says? If p-value goes below 5%, we will use the data and believe the statistics and take a decision. If p-value is more than 0.05, we will simply ignore making any decision. Probably you can go for one more round. So now this is falling under which test? One sample.
T-test.
Come on. One sample T test. So you go to stat, go to basic stat, come to one sample T. Can you read the description?
Determine whether the mean
Determine
of
whether the mean of a
Yes,
sample differs significantly from a specified value.
The appropriate scenario right now, isn't it? The sample mean fat content of the sample, we are going to compare again 15%. So click this. And now how do you have your data? You have arranged your data in a single column, right? So select that. And then click in the center, this white color box. And now you have to tell which column contains your data. C5 contains your data. So click and select. Now you have to tick here, perform hypothesis test. What is the fat content reference value?
15.
50.
Fat content exercise is not there in that Excel file.
No,
Just
it
I
is
was
there.
checking.
The name of the sheet is cooking oil fat content, cooking oil. It's there, cooking oil. In that same Excel file, look for the sheet with the name cooking oil. Just now I picked up from there only. Okay, I'll show you maybe the Excel also. Wait for it. So now I am typing 15. Go to the option. Now what hypothesis testing is it left-tailed, right-tailed or two-tailed? What test it is?
Left tail.
Huh?
Left. Left tail, sir.
You are not following me. This is not. What are you checking? Which side is your failure?
It should be right tail, whichever exceeds
Your failure is,
15%.
if the fat content is found more than 15%, it's a failure. If your failure is on the right side, how can you say it is left tailed? Understand the logic, it's right tailed. And what is the confidence level? Always minimum 95% confidence level. If the company is declaring you make it 99, then you must type 99 here. If your company doesn't say anything, standard practice is 95. Confidence level 95 means level of significance is 5. Alpha risk, type 1 error, all are same, 5%. Now you give okay, give one more okay. Now Minitab is taking care of all your steps. Right? You don't have to do any calculation. All the calculation which you have to do is now performed by this software. So you are now AI enabled. You don't have to do this, right? So now the P value, can you see the P value getting generated? Now just tell me, is this P value above 5% or below 5%?
Below.
Since P value is below 5%, that is less than 0.05, you can reject the null hypothesis. You can reject the null hypothesis. If you can reject the null hypothesis, what does it mean?
You should not take, you should go,
The
should not
information,
take this in addition.
I'll type. The information contained in the data is significant. Isn't it? If something is significant, you can believe in it. You can now believe your data and make a decision. Now, since you can believe the data, I want you to look at the average now. Look at the average now. What is the average fat content of your supplier?
16.6.
16.6.
16.6.
So he is now considered unfit. The cooking oil supplied by him are declared to have more than 15% fat content. The risk in your decision is less than 5%. So you can confidently reject that supplier. So what is your conclusion now? What is your conclusion?
Reject the supply.
Don't buy from that supplier. See how we are using the statistics. All of you understand? Always any hypothesis testing starts with fixing the alpha. Fix alpha. Alpha is always fixed, assumed to be 5%. What is alpha? This is known as level of significance. Level of significance is 5%. Now, what is next step? Frame, null and alternate. What is your null here? Fat content is less
Within
than or
limit,
equal to
less than
15%.
Then
This is null. A statement of innocent. Then what is alternate?
the fact that
Alternate
it's more
symbol
fat
is
content is
H1.
greater than.
Very good. This is H0. Now here, the alternate is fat content is more than 15%.
more than 15%.
Now you refer data. Here, how we refer data? We purchase the samples. We purchase the samples, right? That means you are doing some experiment. And then the sample average is the statistics. Sample average is found to be 16.6 for 16.6%. 16.6% with a p-value of how much? With a p-value of 0.008. With a p-value of less than 5%. When p-value is less than 5%, we have to make decision. What is our decision? Reject null hypothesis. If you are rejecting null hypothesis, what does it mean? The supplier cannot supply the food product with a fat content of less than 15%. Isn't it? So we are able to reject the null. We are able to prove that the null is wrong. So practical conclusion. The statistical steps are okay, but practically what will be our final decision? We decide not to buy from the supplier. That's all. The decision is don't buy from supplier. Don't buy from that supplier. That's all. So the supplier is disqualified. Now, by doing this practice, what is the benefit you are getting? What is the benefit? You are not rejecting the supplier randomly, isn't it? If somebody repeats the same experiment with the same supplier, he will also make the same decision. At least 95% of the time, the same decision, others will also be making. Only 5% of the time, the decision can be opposite. So you are ensuring that the risk involved in your decision is below 5%. So you are not harming anyone, isn't it? At the same time, you are making the right decision for your company. Now, the name of the test is what?
Sample t-test.
If you are asked to audit two suppliers, supplier 1 versus supplier 2. Now, what is the test you will be
Two
performing?
Sample t-test.
Two sample t-test.
If you have to compare yourself with, your friend, you are performing two sample test. And if the data is continuous, it is t-test, two sample t-test. If you have to validate or compare 10 suppliers, then you are performing ANOVA.
ANOVA.
So I think this you have discussed yesterday in detail. I only wanted to just, recollect. So I want you to do the same steps for root cause validation. Any statement, statement can be about a supplier. Statement can be about a root cause also. Can be about a factor. I say that the factor is the root cause. Then what is this statement? What is this statement? Alternate. If I say factor is not a root cause, then what is the statement?
Null hypothesis.
That's all. Yes, madam. What is your question? Samya ma'am. Yeah.
So in this, how did you frame the hypothesis statement? Like a fat person is less than or equal to 15. Normally null, previously sir told to have some, if it is not meeting the, I could not follow the
Null is the current status quo. We have a supplier. We believe that he is supplying quality material. That is our belief, isn't it? That means what he is believed to maintain a fat content of less than or equal to 15%. That is your current belief. The current belief is null. All right. See he might have told you statement of equality. What is the equality here? Less than or equal to 15%. Right?
statement of equality.
Statement of equality or statement of no impact or statement of no difference. These are all null. See, very simple. We are trying to understand whether the factor is making an impact or not. There are only two statements possible. One statement is, yes, factor makes an impact. If you say factor makes an impact, then it is alternate. Then what is the opposite one?
Factor doesn't make impact.
Doesn't make any impact. Then that is your null. You should always frame the null hypothesis in this manner only. A statement of impact is alternate. Statement of no impact is null. If no impact, before, after will be same. That's what we call it equality.
Here it
All
is less than or equal to 15%. How it is statement of equality?
Less than or equal to. See, we see there are, please note, there are, multiple definition exist, right? Statement of equality, statement of no impact, statement of no difference, and the statement of current belief. The statement of current belief. What is your company's current belief? Why did you
It is
consider
less
the
than-
supplier?
It is less than 15%. That is the current belief.
That's why you consider the supplier.
Mm.
So that belief is your null. You write it as it is. He can supply with the fat content with less than or equal to 15%. That is your belief.
Mm.
So whatever,
Current belief is null.
Hmm?
Current belief is null.
Yes, current belief is null. All right. But no, you have to slowly internalize your learning. And then, at the same time, if the current belief is like, if the statement conveys impact, then it should be considered as alternate. Right? You write the current belief in a way that the factor doesn't make any impact. All right. So
But if
factor
the statement is not written correctly, then the entire result will go wrong.
yes, correct. If you start with the wrong note, then you will end with the wrong note. That's all. What all of you have done yesterday, then it seems like all of you have not utilized your time properly yesterday. You're asking now a lot of questions. Yesterday, you should have asked all of this. Right? Because my today's job is to talk about the next level, improve and control. But however, anyway, this is very important, nothing wrong. Anyway, we may have to spend some extra time. All right. Okay. So for root cause validation, your alternate will be factor is the root cause. Your null will be factor is not a root cause. You frame in that manner. Let me tell a scenario. Let's say there is a company where the boiler efficiency is poor. Boiler efficiency is poor. Now we want to fix the problem. And people are saying that, sir, the operating temperature is wrong. Now what is Y here? Boiler efficiency. What is X here? The operating temperature. The operating temperature of the boiler is 800 to 1000 degrees Celsius. Last so many years, the company was running the boiler in this range only. But all of a sudden, they are telling, no, sir, operating temperature is wrong. Now, what is the null hypothesis here? Tell me.
Operating temperature is not affecting the boiler efficiency.
Operating temperature is not critical to efficiency. Yes or no?
Yes, sir.
And so the opposite will be alternate. So alternate. Operating temperature is, you remove the word not. All right. And now you have to refer data, right? Refer data. You will have X value, you will have Y value. Let me type something here. Operating temperature. Here it is efficiency. Operating temperature and efficiency. So operating temperature is from 800 and then 850 and then 900 and then 950 and then 1000. So many, like, you have different operating temperatures and the boiler efficiency is getting recorded here. 60%, 65%, 70%, 75%, and then 80%. Now, what do you understand out of data? Tell me. What do you understand out of the data?
The rising of temperature will increase the rising of efficiency.
Yeah, we clearly understand by looking at the data, whenever the X is changing, you see Y is also changing.
It's a positive
Isn't it?
correlation.
Positive correlation and all of these things. And now it looks like, the operating temperature is critical to efficiency, right? So we go here. Operating temperature. So I want you to always, bring any scenario into a scenario of hypothesis testing. You write the null, write the alternate. And then, you refer data. And then you calculate your statistics. And then you see the p-value. And then, you take a decision. And suppose once you understand operating temperature is, if it definitely in this scenario, it will happen to reject your null. Am I right? If it happens to reject the null, what does it mean? The operating temperature
It's not critical
is
to
the root cause for poor efficiency. Clear? The conclusion. Now we have to think about the solution. Before thinking about the solution, it is a good idea to understand the relationship between your X and Y. The relationship between your X and Y. Why you should know that? So that you can make the right change, yes or no? See, hypothesis testing for now confirmed that a change is required. And now what is the right change? You have to now change your operating temperature. Should I increase your operating temperature or should you decrease your operating temperature? Can you maintain the same range or do you want to shift the operating temperature to a new range? This is going to be the solution, yes or no? So for that purpose, if you have data, you can study the relationship. Let me show you how you can study the relationship. That's why yesterday you studied about the scatter diagram and correlation. Am I right? So let us study the scatter diagram, study the relationship between operating temperature and efficiency. Go to graph, go to scatter plot. And now the scatter plot, simple scatter plot. Okay. And now which is your Y variable? Which is your X variable? Your Y variable is boiler efficiency. Your X
temperature.
variable is the operating temperature of the boiler, which is, currently 800 to 1000 degrees Celsius. You give this and then say, okay. Now this is your scatter diagram. And now what do you understand by looking at the scatter diagram, by referring the scatter diagram?
Positive relation.
The efficiency
The
is
relationship
increased.
is found to be positive and the relationship is static. It remains positive throughout the range. Can you see that? And the relationship is also found to be a perfect positive. Right? So that's yeah. So if you are happy with the current operating range, and if you want your boiler to have, let us say, an efficiency between 80 to 70, then 80 is this point, then 75 is this point. Now you should decide to operate your boiler in this range. What is the range? If you operate your boiler between 950 to 1000 degrees Celsius, then you will be able to achieve an efficiency of 75 to 80%. So what can be our solution? What kind of change is required is coming out of your understanding about the relationship between the root cause and your output variable. Can you see that here? See, you can always, take decision randomly, trial and error. And you can also always, refer to data. Data is guiding you what to do. But how will you control the operating range of the boiler? Can you control it manually? Or do you want some electronic system, sensor kind of thing? That you can brainstorm and decide. Or you see how others are running the boiler. Benchmarking. That is part of your improve phase. But this piece of information is really, really helpful. Yes or no? Okay. See, if the lines are aligned in a perfect straight line, we call it perfect linear. But not all boilers will be behaving in this manner. Sometimes you know what happens. the relationship, boiler efficiency will increase in some certain interval, and then it will decrease in the next interval. Your curve can also be like this, isn't it? There is no rule that it should always be linear. This is called a non-linear scenario. And now also I want my what you call the efficiency to be between 75 and 80. Now I have some flexibility. You see, 925 or 910. Now I can operate my boiler between 875 to 925. If I operate my boiler in this range, always my efficiency is in the expected range of 75 to 80. Yes or no? Suppose I want more efficiency, 90%, then probably I have to think something outside the current range. Extrapolation, isn't it? If you want to achieve 90% efficiency, then you may have to operate the boiler beyond 1000 degrees Celsius. Now you check whether your boiler can withstand beyond 1000. If it cannot withstand, there is no option. That means there is you need to look at some other factors for further improvement. This factor can only improve this much. Clear, all of you? Now, this is how scatter diagram should be used. The scatter diagram is listed under one of the 7 QC tool. Many organization should be good at using all the 7 QC tools. That is a starting point. If they don't even use the QC tools, then talking about quality has no, it doesn't have a purpose. So the QC tools must be, everyone should be thorough in any kind of business, not necessarily, manufacturing, even in service. So this is how this tool is helping. So now you understood the relationship can be positive, relationship can be negative, relationship can be linear, and this is known as non-linear. Is known as non-linear. So you must know whether your X and Y are related linearly or non-linearly. Whether your X and Y is related linearly. So once you have all this information available on your table, and you have brainstorming happening with your project team, will you be able to talk correctly? Will you be able to guide your team in the right direction? And if all your team members are also green belts, they also know all these statistics and everything, then it's a fantastic scenario in your company. Everybody is thinking very correctly, and they talk very sharply, and that really can actually accelerate the organization's growth. So if you really want such a scenario to happen, you can nominate your team member for the next upcoming program. All of them will be like you, right? And you can have so many green belts, black belts in your company, and then talking so nicely about any problematic scenario, and then you will be able to fix the problem as a problem in any scenario. Because just you as a single person, you can't bring about the change which your organization needs. You have to build a team, and the team should also think systematically. They should understand your language, and all that should happen. So let me also show how the correlation analysis can help you in this scenario. How the correlation analysis can help you in this scenario, right? So delete. Okay. So now I want you to go to stat, go to basic stat, come to correlation. Stat, look here the description, measure the strength and direction of the linear relationship between two variables. The variable should necessarily be continuous variable. Temperature is measurable, efficiency is also measurable. So now I have to choose the variable, temperature and efficiency. I choose both, and then I give OK. And now Minitab calculates the coefficient for me. Pearson correlation coefficient is how much? R equal to 1. The maximum possible is 1 only. 1 means 100%. 1 means 100%, right? So R equal to 1. So I want you to calculate what is R? Correlation coefficient. There is a strong, perfect, positive correlation. I want you to calculate R square. The R square is known as coefficient of determination. What is R square? R square is
Square root of R.
not square of R. R square is square of R, not square root. So 1 into 1. 1 into 1 is 1. When you square the R, it is known as coefficient of determination. Now this 1 means 100%. This 1 means 100%, not the previous one. Right? The R is squared. Now it becomes again 1. So in terms of percentage, it is 100%. Now this 100% is giving you a piece of information. The 100% of the variation in boiler efficiency. Boiler efficiency can be attributed to the variation in the operating temperature of the boiler. Do you understand? Is this statement helping you? What do you understand out of this statement?
Both are positive correlation.
Still correlation, but now based on the R square value, I'm writing this statement. 100% of the variation in the boiler efficiency can be attributed to the variation in the operating temperature. If the operating temperature is controlled, then boiler efficiency will also get controlled. You don't have to do anything else. Now the operating temperature is the only root cause for the variation you are witnessing in the efficiency of the boiler. You don't have to look at any other root cause. Now your analysis is over, provided you maintain the conditions of the experiment during your daily operation also. Whatever conditions you maintain in the experiment, if you can maintain the same conditions, then the only challenging factor is what? Operating temperature. You don't have to do anything. Only control the operating range. We just now we discussed, right? Operating range will be 950 to 1000. You do that, then definitely the boiler efficiency will be around that 75 to 80%. All of you understand what I'm telling? That means your boiler efficiency is currently getting influenced only by the operating temperature. No other factor is affecting your boiler efficiency. Clear?
Is it the same called that Pearson correlation?
That's what.
Is
This
it
is
written
R
there?
is Pearson correlation coefficient. But when I square this, it becomes coefficient of determination. See, if it is 1, both will give 100%. Suppose if it is not 1, let's say it's 0.8. Then what will happen? R square will become 0.8 into
80
0.8 is
Oh, yes, 80%.
0.64 only.
0.64.
0.8 when square, it will become 0.64. That means,
Yes, yes.
64% impact is coming from the factor. If you fix this factor, only 64%, you will be, of the problem you will be able to control, not beyond that. That means, there are some other factor you need to include.
Correct.
Let me give you a simple example. Any decision you take in your family, your decision will be influenced by the family members. Yes or no?
Yes.
Who are the members
Yes,
in
sir.
your family? Your spouse, your children, and your parents. And tell me, who will be having the major influence?
Correct.
Your parents, really?
Correct.
Nowadays, it's a very rare scenario. Okay, maybe in your family, that means it's a great family. Okay, you listen to your parents. Your parents have a major influence. So their R square is higher. Their influence is, let's say, 80% or something. But in majority of the family, the spouse has the major influence, isn't it? And here, the operating temperature is acting as a spouse of your boiler efficiency. The boiler efficiency listens only to the operating temperature, like how you listen only to your wife. If your wife says something, you are all done. You are not listening to the other factors. See, the scenarios can be different. Please note, in some family, someone may be listening to the spouse also, listening to the kids also, listening to the parents also. It can be all 33%, or it can be 80, 10 and 10, or it can be 100, 0 and 0. If the scenario is 100, 0 and 0, what does it mean? 100% for the spouse, 0% to the children, and 0% to the parents. What does it mean? You are not at all listening to your parents. You are only listening to your wife, isn't it? And now such a scenario exists here. 100%. That means the only influencing factor is what? Operating temperature. If you correct the operating temperature, problem is solved. All right? But if you are not getting 100%, the situation is demanding you to use the next tool. Your problem cannot be solved with just hypothesis testing and correlation. If this is not coming out to be 100%, the game is not over. The analysis is not over. You must necessarily go to the next tool, which is, I'll type it here, and that we will be teaching you in the next levels only. The tool you need to use now at this stage is design of experiments. When to go for DOE? When to go for DOE? When the R square is not satisfactory. When the R square is not satisfactory, that means more than one root causes exist. All of you understand? Whenever more than one root causes
when we will means take a call that yes, now that R square is not satisfactory, is there any recommended means percentage is there, or any? It's a 64%, 50%.
80%. Anything above 80% is is a good influence, and you will see a good improvement.
Below 80% means?
Below 80%, that means definitely you have to consider including some additional factors.
Other factor. Yes.
Right
so
now,
at that time, you have to go for a design of experiments.
Yes, right now you think that your Y, what is your Y? Your boiler efficiency. Your boiler efficiency is a function of the operating temperature. Why you are considering your boiler efficiency is only depending on the operating temperature? Because all other factors are under good control already. That is your assumption, isn't it? Like you don't listen to your parents. Your parents are just, but it's a constant. Please note. The other factors will have some influence, but those influence are constant. So I just put a constant here. Please understand. What is this C refers to? C refers to the effect coming from all other factors. The effect coming from all other, that's a fixed effect. Please note. That's a fixed effect. You don't have any challenge in getting the fixed effect, isn't it? But your challenge is only with the operating temperature. So this is what we mathematically express as Y equal to mx plus C. Yes or no? You might have studied, right? Y equal to mx plus C. Now, how many x factor is there in your equation? How many x factor is there in your equation? Only one x. You can use this equation only if you have a healthier R square. If your R square is not healthier, please understand you are believing in a wrong equation. How can I improve my R square? By finding out the other root causes. Suppose if there is one more factor, let's say x2, ax1, bx2. Look at my equation now. How many variables I brought in my equation?
2,
2.
3. Huh.
So my boiler efficiency not only depends on the operating temperature, it also depends on, one more factor. So by including one more factor, by controlling one more factor parallelly, I can have a better control over my boiler efficiency. Is it logical? So this equation, if you can write this equation, this is known as regression equation. In your regression equation, if you want to write a regression equation, you should know A, you should know B, you should know C. Yes or no?
Yes.
You will be able to find out the correct value of A, B, and C only if you use the tool DOE. You have to conduct experiment in a very well planned. If you conduct the experiment in a planned manner, without giving any room for any kind of error, then you will be able to write the equation in a correct manner. That's a confirmation that your analysis is over. All of you understand? So
Sir,
we will be learning DOE the next week. Okay. Yeah, any question?
sir, this regression equation, can you just repeat once again?
No, see, if you can see what is happening in your process, if you can express it mathematically, that mathematical equation is known as regression equation. In order to write a regression equation, first of all, you should know how many significant factors are affecting your result. In the current condition, my result is influenced by operating temperature of the boiler. My boiler efficiency is also influenced by what can be other factor in a boiler?
Maybe atmospheric conditions.
Atmospheric condition. Okay, atmospheric condition may be uncontrollable factor. You must live with it. You can't control atmospheric conditions.
The
Maybe
flow of cooling water.
very good. The flow rate of the cooling water. And see, so all the significant factors should participate in your equation. See, the X factors will participate in your equation if all of them have an operating range. If there is no operating range, if the X has a fixed value, then that will be taken care by C. Do you understand what I'm telling? If the flow rate is fixed already, that will not appear as a variable. That has become a constant. Do you understand? Flow rate is always, fixed value in my boiler operation. That means it is not a variable. The effect of the flow rate will be taken into account in this part, C. That will appear as C, that's all. So only the factors which you have, for which you have a range of operation, right? If the value is in a range, then that will, those are the challenging factor. Operating temperature is 800 to 850. Why do you have a range? Why you are not setting a single value? Why are you not setting 825? It is difficult for you to run the boiler always at 825, isn't it? So that is a significant factor. That is a critical factor that will be part of your regression equation. Clear?
So, sir, we will consider R square value. If it is more than 80%, then we should go for this equation, y equal to mx plus c.
Yes. If your R square is more than 80%, that means you have understood your process very well. You have the enough expertise to make changes in your process. If you cannot write down an equation with an R square of 80% and above, it simply means you have still not understood your own process.
Then at that time, we have to go for this regression equation, right?
See, see, regression equation is no just writing down the scenario in the form of a equation. But why are we writing? We want to really, understand how much we have understood about our process.
This is actually decisive tool, correct? This
This is
regression
a
equation, decisive tool means decision making tool. You can say that
yes,
regression
all
equation.
yes. That yeah. See, yeah, all the statistical tools are decision making tools only, right? See, you can always say I know everything about my process, but if you really know, you should be able to write it in the form of an equation. Correct? So, and then once you show me your regression equation,
So just for my clarity means so suppose that histogram and all these things, can we say that the decisive or indicative tools?
see, histogram is again that is one of the 7 basic QC tool.
Yes. So
All the graphs are giving you only visual representation of the data.
correct.
That's all. It's only visual representation. But here now we are actually going for the statistical analysis,
Okay.
right? So see, what to say? Whether the data is actually misleading or not, that you get to know only if you look at the analysis, not just looking at the graphs. By looking at the graphs, you will be tempted to make so many conclusions. But if you look at your analysis and then a higher p-value, then you know whether to believe it or not. So the chance of the data, misleading you should be below 5%. And that's why, we use the p-value. And so see here, the regression equation I am showing here only to let you know that whether you have identified all the root causes or not. If you frame a regression equation and at the same time, if the R square is 80% and above or close to 100%, you have done a great job. You have done a great job. It's a confirmation that your analysis is over. You can proceed to the next phase. But however, if R square is not 100%, let me show you another scenario of R square not 100%. So here is my Excel and laboratory that let me go to hydrogen content, one file, hydrogen content and porosity. See here, hydrogen content versus porosity. I want to understand. Here, one of the root cause for the porosity in my casting is hydrogen content. So I copy paste this data, first of all, in Minitab. Let me paste it here. Now, what should I do? I should perform the correlation or regression, right? Maybe go to stat, basic stat, correlation. Choose the correlation. So remove this, choose these two. Select, give OK. What is your R value here? What is your R value?
0.625.
Okay. So find out the R square. 0.625 multiplied by 0.625. Tell me. 0.3904. Now, what is the statement you need to make now? 39.04% of the variations in the porosity can be explained by
Hydrogen content.
the variations in the hydrogen content. So what do you understand out of this statement?
There
Hydrogen
are some
content-
other factors.
How much
Perfect.
influence your hydrogen content has got? Only 39%.
Oh,
According to the data, please note, according to the data, all these statements are valid only under the conditions of your experiment. If you perform the experiment in a particular setup, but if your daily operation is, in some other setup, all these findings are useless findings. Do you understand, all of you? Always, when you perform experiment, you should perform the experiment in the real life condition. In a real life, all the factors will affect your result simultaneously. In real life, all the factors will affect your result simultaneously. Yes or no? Everyone around you will be troubling. You simply think that, all of them will trouble you only one at a time. No, one at a time is an assumed scenario. That's why hypothesis testing, in hypothesis testing, we study the factors one at a time. But in real life, all the factors can influence your result simultaneously. So studying all the factors simultaneously is design of experiments. That is why I told you, your analysis will get over only after you perform DOE. But in certain cases, if the problem is simple, if there is only one root cause and you rightly found out the root cause, then there itself you get an R square of 100%. You understand, all of you? If there is only one root cause, if the problem with only one root cause, and you identify the correct root cause correctly, there itself your R square will become close to 100%. There itself your R square will become above 80%. So you don't have to go to the next level and all. But if there are multiple root causes, but you are only working with, you have only found one of the root cause, in that case, you will have a problem with your R square. If you have a problem with your R square, you must alert yourself. You have something else to do, yes or no? So this is the piece of information you are getting, right? So we got this correlation performed. And in this condition, when my R square is 0.39, if I frame a regression equation, do you think my regression equation will have the required quality? No. My R square is poor. And so it is not advisable to frame a regression equation. Your regression equation cannot speak the conditions properly. So you must necessarily include other root causes. You must include all the root causes. Also, you must choose the proper relationship. Relationship or can be of two types, I told you, linear, non-linear. Linear means all the x will appear as x. Non-linear means in addition to the x square will also appear. If the relationship becomes cubic, x cube will also appear. But you don't have to go through the pain of doing all this mathematical stuff. Feed the data, make the Minitab to do it. I can also show you how the regression equation can be for the hydrogen content scenario. Even though the regression cannot be a proper fit, I can still show you a regression equation. See here how simple it is. Go to stat, go to regression, go to fitted line plot, choose your y variable. Tell me what is your y variable?
porosity,
Your x variable is?
hydrogen content.
Hydrogen content.
And now, what do you think the relationship is? What is your guess? Can it be linear, quadratic? You can also make a guess, because it's a matter of clicks, isn't it? You can try everything also once. Everything one time you can try, and whichever comes out to be the best, that you can accept. Or you plot a scatter and make a judgment, right judgment. Right now, I'm just simply believing linear, and then I'm giving okay. And look here, my regression equation has come. Can you see here? My regression equation is nothing but the red color line, what you are seeing here. Is this line properly passing through all the points?
No.
No, sir.
It's not a proper
No,
fit.
no.
It's not a proper fit. The quality of the regression is very, very poor. And that means, it's only, beginning of your analysis. It's not the end. Probably if you study, include a few more factors, then, all the points will start aligning properly. Okay. So studying multiple factors together is a different subject. And the name of the tool is design of experiments. That we will take it up separately. Don't worry. Right now, as a green belt, you will be working on projects of lesser complexity. Lesser complexity in the sense, not too many root causes, just one or two root causes, or only one root causes. And if you identify it correctly and fix, and then, frame the regression equation, you will be happy to see a good R-square value of 80% and above. And then you can move on to the next stage. Is this discussion helpful, all of you?
Yes, sir. Sir, could you share this Excel sheet, because I don't find this Excel sheet is there.
Really?
So it would be helpful for us to do some
Okay.
kind of
Sure. Definitely. So what is your batch number? BBE 54, huh?
Yes.
Sir.
No, it is just now shared. Somebody shared.
No. That's a different. All these exercises are not there.
Oh, okay.
I only shared that.
Okay, version 5. I will be sharing version 7, the latest I have. No, this contains data, correct? Yeah. Can you see here? I have shared it right now.
Yes.
Please download and keep it. BBE.
Yeah.
And similarly, what is the other number? BB 44 and Greenbelt. What is your number, batch number? GBE 68.
Yes, sir. GB is 68.
Okay, I forwarded that also. Okay, very good. So now that is available. And Minitab installation link also I gave, right? Minitab installation link. If you want to practice using Minitab, you can do that. And I have shared that also along with my LinkedIn link and YouTube link. If you want to just follow me in the social media, yes, you can do that also. All that I have shared. Okay. So see, all of you, do you at least understand what are we actually doing in the analysis phase? Don't do anything blindly. There is no use otherwise. You should know why are you actually performing scatter analysis? Why are you performing correlation? Why are you performing, looking at the regression equation? Why should I look at my regression equation?
To find the root cause properly, which is having the high correlation or high impact on the Y.
Exactly. To understand which are all the factors currently influential to my result.
Yes.
It's basically to check the relationship between two factors.
See,
Whatever.
imagine
factors.
one of your health metric is not satisfactory. Then what are the factors that are influencing your health now, right now? Let us say, sugar level is very high. Sugar level is very high. Now tell me, what are the influential factors? See, please note, you have poor control of certain factors. That is why your sugar level is high. Yes or no?
Yes.
Consumption of most.
So it is very essential for you to know those influential factors. So you are supposed to write an equation where all the influential factors should appear in the equation. If you can't write down the equation, it simply means you don't even know which are the influential factors. Tell me then, how are you going to control your sugar level? All right. So if it is sugar level, if you have proper control over your calories, that need not be part of your regression. If you are foodie, eat too much, then calorie consumption is part of your regression equation. Do you understand? For certain people, I am advising to include the calorie consumption, but for some other people, I am not advising. You know why? Because they are already having a good control. They eat, only the required quantity. For them, consumption of food is not a problem. The next influential factor is, your exercise, your activities done every day. Everything I should make it measurable. Please note how many steps you are walking, how many hours or how many minutes you are exercising. If you simply sit throughout the day, you have a poor control over such factor. That should definitely be, part of your regression equation. All influential factors should appear in your regression equation. Your dinner time. Do you think your dinner time is an influential factor?
Yes.
That should also appear in your regression equation. If you are not able to see the influential factor in your regression equation, tell me honestly, how are you going to control your sugar level? Isn't it? If some factors are influential, you allow the factors, to dominate, what will happen to your sugar level? It will shoot up, isn't it? So if you expect a good control over your Y variable, then you must definitely have good control over your X variable. If you have very effective control, some point of time, the X variable will become a constant. Suppose somehow you identify good foods and standardize your eating pattern. You are not giving a chance for the food to trouble you. Yes or no? You have found out the good food, you have found out the right amount, and you standardized your eating pattern. Every day morning, I will take this. Afternoon, I will take this. Evening, I will take this. Now, this factor, is made a constant. Do you understand? So once you make a factor as a constant, that means, you have gained a good control. You don't have to worry. But all factors which are varying too much, or the troubling factor, or the critical factor, or the significant factor, all of them should appear in your regression equation. If all the significant factors are not appearing in your regression equation, your regression, is of poor quality. The quality of the regression equation is unacceptable. We assess the quality of the regression by looking at a metric known as R square. Looking at the metric known as R square. What is the name we have given to it? Coefficient of determination. If R square is not 80% and above, your regression equation is unacceptable. Your regression equation is unacceptable. Another way your understanding can go wrong is the relationship. Not only the inclusion of significant factor, the relationship of the significant factor with your Y variable. The relationship can be positive or negative. Now, what is your understanding? The relationship can be linear or non-linear. Now, what is your understanding? Within non-linear, relationship can be quadratic or cubic. Now, what is your understanding? Is my questions logical? The beauty is you can find out answer for all these questions through your experimental data. You don't really require, an expert to come and teach you. You can turn yourself into the real expert, but it requires some effort. Some, experiments you have to perform, and you should look at the data, analyze the data, then you will understand. Okay. Ashim Dey, why are you not receiving? In which group you are there?
Sir, I also did not receive, sir.
So where are you?
Sir,
In which group you are there? You are in which WhatsApp group?
I am into
Sir,
BB
this one.
54 COE training.
This one. BB
BB?
54 OE training.
54 OE training.
Oh, BB54 OE training. Yeah, okay. So many names. That's a confusion. Okay. So I will send that to 54 OE also.
Yeah.
Sir, for GB 065 also.
1 second. I'll do that. 54 OE I have done. What is the next one?
Yeah, got it, sir.
What is the next one? Another group?
Sir, GBE 065.
GBE
068, sir.
GBE
68.
065. I don't find anything like that. GBE.
Sir, GB 68.
Oh, GB 65. Okay. GB 65.
68,
Then
sir.
or.
60.
Come on, sir. Please repeat. I am not getting you. GB.
GB 68, sir.
Oh, GB 68. Okay. GBE 68. Okay, I got it. I'll share. But already I shared Minitab there. Already I shared. It is showing. Why are you asking me to share again? It's there already. I'm sharing it one more time also. I've shared it one more time. Please confirm if you can see.
Sir,
All
any
right.
specific access required for that OneDrive, sir? Because it is asking, throwing error actually. I'm not sure.
You
I'm
are not
getting
able to
access
download?
denied.
Oh,
Yeah, because
really?
we are getting access denied. I'm getting, sorry.
For Minitab, right? For Minitab.
Yes.
Okay, I'll check and then repost it. Don't worry. But Excel file you can download and then use it.
Yeah.
And Minitab, I will just check one more time after the session. So, okay. So coming back. So you now understood, right? What are you doing in the analysis, right? You are
Sir, one
streamlining
query.
your thinking, you are streamlining your decision, and you are making sure you are correct before moving forward. You can always move forward without doing any of this. Your approach is known as trial and error. But if you do this, your approach becomes systematic. There is a double guarantee that your actions can fetch the expected result. So with that, we are moving on to the improve and control, right? So before we move on to improve and control, I want to give you some rest, all of you. Okay? Because you have learned so much in the analysis area. And so, wait, okay. Please take some break and then shall we meet by 8:50? We have 11 minutes, right? And then we'll continue and I'll take you through improve. See the improve, see if the analysis, if you work hard in the analysis phase, you can work comfortably in the improve and control phase. Not so serious. It's all of brainstorming, discussion, team meetings, and coming to a common agreement and then taking action. Right? So we'll talk about that in the after the break. So we are done with the analyze phase. We have identified the root cause. We validated the root cause. We have also understood whether we have identified all the root causes or are there any gap. If you have identified all the root causes, if there are multiple root causes, then how much influence is coming from each of the root cause? How much influence is coming from each of the root cause? So so all this piece of information we have understood. We also studied the relationship of each root cause with our output variable. Whether it's positive, negative, linear, non-linear, quadratic, cubic, all that we understood. And it is very evident from the regression equation also, right? So definitely your little gap in this analysis part will be resolved once you master the tool known as design of experiment. That will happen next week, next Saturday, Sunday. We are going to have a full day session 9:30 to 5 and where we will be spending quality time to understand the DOE and the regression. And over and above, I will introduce you to some wonderful additional tools in every phase: define, measure, analyze, improve, and control. And that will definitely, give the complete picture of the any improvement project, particularly the DMAC project. Now let us move to the improve phase. Now, what is our goal now? What is our objective now? Solution. Our goal is solution. Now, how can we generate solution? If a similar problem exists in another company and they have solved it, now they are better than you. can you go and study their solution? Possible or not? This practice is known as benchmarking. It is not necessary that you should only go to a company bigger than your company. No. If the company has a better process than yours, then you can go and study. That is, the benchmarking. Sometimes you can benchmark processes within your company also. Maybe the other department, maybe having a similar process, but with a capability better than yours. You can benchmark certain process from other department within the organization. But what you need to do is you have to do it ethically. Take their permission and then, study it and then implement it. Academic researchers can also be a good source of benchmarking. All of you agree? Many people have done research years together. They have worked hard. They used all these tools and published in some, journals, some good, journals, peer-reviewed journals. So, as part of the MBB program, we will be making you to go through 1 or 2 research papers also, such papers. So, those papers will have a content, of a higher quality than a real-time project carried out in an industry. Right? Normally in an industry, people, they do the project in just 3-4 months time. But if it's a research project, they do it in 3-4 years time. Imagine. So they take care of, all those, errors and then try to control them. So you will find a high quality content. So that will be discussed as part of the MBB program. If some of you are planning to such a level of learning, you can consider joining our MBB program also. And our Sadashiv is already part of our MBB program. So we are commencing this week and coming weekend. All right. So that's one thing. So benchmarking is one tool I have told you. And another thing is, again, you can go for a round of brainstorming. If the problem is known, root cause is also known, will you be able to generate solution? Easier, isn't it? Let us talk about, a real-time problem just to, keep the session interesting. So how can we ensure active participation of the participants in the training program happening around 9 p.m. to 10 p.m. right now? People have the tendency to sleep. People have, they feel hungriness for the dinner, and it's a Sunday. So there are so many problems, so many root causes. And root causes are, of course, known because we have done the analysis. Now I expect all of you to speak in terms of the solution, not in terms of the problem, not in terms of the root causes. Please speak in terms of the solution. Even if you feel shy about coming on the camera and speaking it out, you can type it in the chat box. Everything is a technique, isn't it? Ultimately, I want everybody to participate. So let us start with maybe Sadashiv. Sadashiv, what do you think? How can we make our sessions very, very effective even after 9 p.m. in the night?
We can make it more interactive, some kind of real-time examples,
Okay.
live examples.
So real-time
which
example.
can means.
So the discussion is exactly a real-time example. Right now we are experiencing, right?
Yes.
Good. Okay. Real-time example is his point. Okay. Vyas, what do you think? Come on, quick answer.
Every now and then ask questions with the viewers and with the participants so that they'll be like
So ensure
glued,
they are
they'll
not
be
sleeping. Okay.
sticking to the course. Yes.
So ask question and ensure they are awake, right? Okay. Good. Arogidas, what is your point?
That's what, sir. We need to ask for confirmation on their understanding, whenever possible, in between, and check whether they are concentrating on the classes.
Okay. Again, questioning the participants. Okay. Ashim, what is your point? You also want me to check all the participants? Tell something on the trainer side, something on other sides. Not always charging your participants.
Something like you are presenting PPT. So in that PPT, if it is like something video or audio visual. So might
Okay,
be
very good point. Oh, playing
something
video, some
interesting.
latest movie clip and latest movie song of your favorite hero and heroine can definitely do the needful, right? Okay, that is one point. Or maybe some video related to the subject can definitely awaken all your participant and then make them involved. Very good. And Mogana Rangan, what is your idea?
Sir, conducting little mock-up test like mock-up
Okay.
is about what we
Okay,
are.
some mock-up test during the session itself, right? After half an hour of lecture or something, just 3-question test. 3 questions and finding out who can answer all 3 questions correctly, who is first, who is last, and instantly. Like Zoom has a feature, instant quiz can be done, and that will definitely, yeah, good idea. Yes, we should do that, but we are not currently doing. Okay. Soumya ma'am, what is your suggestion?
Sir, one thing what I observed with Vivek sir is he's pulling the participants, pulling the participant by calling the names. So without any other choice, we have to listen to him. So
Okay.
that is
Yes, sir,
one point.
definitely.
So frequently calling out the names of the participants
Yes, like
and demanding
did you
them
get that?
to. Okay,
He
that
pulls
is
everybody.
very
He
good.
make it
So
interact.
that is a kind of part of your solution. Very good. And Krishnan,
The second point is
the second point also you have.
the
Yes,
participant has to plan the training session in advance so that they complete the dinner and other things in advance so that they can be available for the training.
no problem. Dinner, if you, all of you want to have, you can have it, parallelly also. I don't mind.
It should be
Okay.
due two sides. No, that is right.
Correct. So it can be well planned so that even in that 10 minutes, something, dinner can be completed. Good. Krishnan, you want to suggest or we go with Mayur or Vagula,
I
right? You
accept Asim Dev. No, so sir, I am accepting that Asim Dev, whatever the set point, even in between the training section, we need to add
Okay.
some
You are
YouTube
already
clips
done
or
that.
yes.
Okay. You don't have any new point. That means we have almost attacked all the
Then
root causes. That is what we could make out. Okay.
yes.
Mayur, you want to suggest? Vagula, you want to suggest? Mallikarjuna Kumar, you want to suggest?
Yeah, we covered all points. Just one point is that poll part. In teams, in our organization, we use the poll functionality where we have predefined 5 questions. So in between sessions, we just launch the poll. So participants will
Perfect.
actively respond.
Perfect.
No marking and all will be there, just the percentage of response for each option.
Understand. Right.
So that will actually help and not judge the participants.
Very good. So all of you attacked almost all the root causes. If you have left out some of the root causes, maybe I can initiate discussion in that direction also, isn't it? If there is a problem with the course material like Minitab and all, you are saying, you are not able to download and things like that. There is a problem there. So that also we can discuss. How can we resolve that? That can be, completed during your registration itself. Isn't it? And so what we used right now is brainstorming. What is the tool we are using right now? Brainstorming. I have allowed each one of you to speak in the order I decide. So the brainstorming is structured brainstorming. But if you decide the order on your own and then you speak according to your criteria, not according to my criteria, right? Like Samya madam was suggesting 2 solutions. I asked one from each, but she suggested 2. In that case, the brainstorming becomes unstructured brainstorming. Clear, all of you? So brainstorming can be used as a solution generation tool. But make sure you invite the relevant people for your meeting, for your brainstorming session. Whom should be invited? People who are really part of the problem. People who are really, part of your process, who are really interested in getting your problem solved. They must be invited, right? make sure, he is one of the stakeholder and then really interested in solving the problem. Otherwise, they will hijack the discussion and then waste your time, and then your, meeting will go in a wrong direction. So there can be structure, it can be structured, it can be unstructured. And who gave the idea of playing videos? Who gave the idea of playing videos? Ashim, right? Ashim, if I have to play so many videos, then how can I cover my syllabus?
No,
Why
not
don't you
so
watch
many
all the videos
like,
offline?
not so many videos, sir. Like it is something real life problem with the things which we are aligned with. So something like that. Maybe some clips of some seconds, 10, 20 seconds or 30 seconds.
So, for a point suggested, I am asking a cross question, isn't it? I'm asking a cross question, and then he is able to give me a convincing reply. That means his suggestion was correct. If he cannot give a convincing reply, that means, his idea may not be, feasible. So this way of cross questioning every idea, every solution idea, and then on the spot validating it is known as critical thinking. A type of brainstorming, nothing, isn't it? It's a type of brainstorming. But in order to have the critical thinking as part of your brainstorming, you must have relevant people sitting in your meeting room to raise the question. Not irrelevant question, isn't it? If needed, you can invite SMEs from outside also. Subject matter experts from outside can also be invited for your brainstorming session so that they can really ask meaningful questions to test the existence of the solution idea. All of you understand? So your brainstorming can be a tool, critical thinking can be a tool, benchmarking can be a tool. How many of you noted? I have even suggested you to type your points in the chat box. Have you noticed it? What am I doing here? I am enabling everybody to participate and share their views. Isn't it? If you use such criteria, that is known as nominal group technique. Some people are shy of speaking in front of others. Some people might be shy of speaking in front of the boss, in front of the management. Some people will be shy of speaking about certain issues, certain points. Issues related to salary, they may not speak out. Yes or no? So can you break all those barriers by categorizing those people and enabling them to speak out? You can give a paper and then ask them to write certain point, or you can ask them to go to separate room and then discuss and then come back. If you do that, that is known as nominal group technique. Even the controversial points, you will be able to capture. Isn't it? Any problem about the trainer, you may hesitate to speak in front of the trainer. Yes or no? Sir, the trainer is not explaining properly. You will not be able to tell that because the trainer is just listening to you. So these kind of issues can be resolved by using a nominal group technique. What is nominal group technique? You will allow the participant to go to a private place, separate room, and then they will discuss freely there, and then the summary of the points will come to the moderator. Whether you give a paper or give them a private room or you ask them to put it in a chat box, it's up to you. Nowadays, technology is available everywhere. So you are giving some private space for the participants to think and then suggest. Then it is known as nominal group technique. All of you understand? These are all different forms of brainstorming we are using for the purpose of generating solution. Now, after generating the solution, you must evaluate. You must evaluate them. How can I evaluate? I can give some kind of scoring based on certain criteria. Maybe for let's say for the suggestion given by our Ashim, he said we have to play videos. How many of you like the idea? You can vote, isn't it, for the idea? How many of you like this solution to be implemented? If all of you say, yes, sir, I like the idea of playing video, at least one video every hour. If there are 2 hour session, 3 hour session, there must be at least 3 video. So if all of you like it, that means solution is evaluated straight away. Yes or no? So now the tool I have used is multi-voting, isn't it? So people are giving the voting, and maybe sometimes I can even go for 2-3 rounds of voting. Possible, right? So ultimately, I want to narrow down the number of solutions. If there are too many ideas, I may not implement all. Like right now, you all told me, so many ideas. Each one of you gave me so many ideas. But my organization can only implement, 5 out of all the ideas. Then I will filter out with the help of the voting technique, right? It can be multi-voting also, right? Multi-voting means you have 2-3 rounds of, voting. So this is how, solution can be generated and then solution can be evaluated. All of you understand? Tools are very simple, but it requires a lot of organizing skill, from the project team, particularly the project leader, to get the job done. Otherwise, it will be a waste of time and, waste of, coffee and biscuits. You have to ensure the coffee and biscuits are used wisely by properly conducting the meeting and documenting it properly, getting the signature and all that you have to do. Then what will happen? It will definitely, have a significant, results. So solution generation is easy part. And in line with the tools I discussed, if you find some other tool, more relevant, nothing wrong, use it. You can use it, right? Ultimately, we want to generate solution, but for discussing the points in this kind of solution generation meeting, all your understanding in the analysis can help to a great extent. That is, important. Then before going to the implementation of the solution, it is always a good idea to implement your solution in a smaller scale. Agreed? This is known as piloting. Let's see what happens if we include 3 videos in the next 1 hour. Right? And are we able to cover the syllabus? Are we able to impress the participants? Right? Is that video is also covering some topics? Likewise, we can do a piloting. If really it becomes feasible, then you go for a full-scale implementation. So piloting is implementing your solution in a smaller scale with an intention of understanding the challenges in implementation. Because whatever you do, it is theoretical. But if you do a pilot study, it is more practical, isn't it? You implement it in the real scenario. That's called piloting. So piloting can help you to understand the challenges you may face during your full-scale implementation. And then you can customize based on your based on your what do you call the knowledge you gained from the piloting. You can again customize your solution and then go for a full-scale implementation. Full-scale implementation should have a proper plan. The communication plan and training should be part of your implementation. If you forget to train your people on the solution, because once you implement a solution, the system will be new, the process will be new, yes or no? And then if you don't train your people on the new process, somebody might think that still the old process in place, and then it can lead to some unnecessary failures. So you can avoid that. So you must have a full-scale implementation plan. And after the full-scale implementation, you should also go for a cost-benefit analysis. Just to open an Excel file, type down all the cost incurred. You know how to include all the cost element, isn't it? The project cost, so much you might have spent. Everything can be documented and then converted into dollars. People who worked on your project, 10 people, each invested, let's say, 40 hours of 40 man hours. 10 into 40 is 400 man hours. Can you convert that into dollars? Possible or not? You need not be very, very accurate in every aspect. There can be different levels of people, but you consider an average hourly, pay. It can be 2,000 or 3,000 or 500 or whatever. It varies from organization to organization, team to team. You find out, the suitable number. You go with the average. An average into 400 man hours. That will be the cost of, the project team. And similarly, other things, whatever happens, any testing done, any machineries used, any travel incurred, and all that can be documented as project cost. And you know how to calculate the benefit. We have taught you, isn't it? Business case. You remember the direct benefit because of the success of the project. What will be the direct benefit? What will be the indirect benefit? Can one of you tell me what is direct benefit? What is direct benefit? What is direct benefit? The immediate savings in the same financial year. What will be the savings? That is direct benefit. What will be the savings in the future? Isn't it? Some additional returns will happen in the future, but definitely certain returns will happen within this year. So that is direct savings, and indirect saving is, definitely it will happen in the near future. Somehow you can convert both into a dollars, and then benefit is also available in dollars, cost is also available in dollars. Now you just compare. If the cost and benefits are same, what will be the cost to benefit ratio? Ratio will be equal to 1. Do you understand? Cost is 25 lakhs, benefit also 25 lakhs. Cost to benefit ratio is 1. That means no loss, no profit, something, break-even scenario. But if the benefits are more, cost is less, I calculate a cost benefit ratio. Cost in the numerator, benefit in the denominator. Now my ratio will be less than 1. Yes or no? We just formulate a metric and then use it for discussion. So cost benefit ratio, if it is less than 1, your project is beneficial. If cost benefit ratio is found to be 0.5, what does it mean? What does it mean? The benefit is double the investment in running the project, isn't it? So, okay. So what happens? The cost benefit ratio can be calculated. So all of these things are part of your improve phase. Clear, all of you?
Yeah.
Now, finally, your solution should also be validated. Your solution should also be validated. Whenever you, hereafter you read the word validation, there must be evidence of data. Now, please tell me, how can you validate your solution? What is the guarantee that improvement is because of your project? Improvement should have happened randomly also. How can you do it? Suppose your project is again data, isn't it? Suppose if your project is reduction of rejection rate. What was the rejection rate before your project? And what is the rejection rate now? Consider a considerable period of time, maybe another 30 days or 60 days. Collect the rejection data after implementing solution. After implementing solution, 30 days production data is collected and rejection is recorded. Original rejection rate is 12%. Now the current rejection rate is just 2.5%. 2.5%. Is this difference significant enough to claim that the reduction is because of the project? Yep. And what is this test belong to right now? You are comparing two rejection rate. First of all, tell me rejection rate. Is it a proportion or average? Rejection rate is a proportion or average?
Proportion.
Proportion. Percentages are proportion. So the proportion defective earlier or before project and proportion defective after project you are comparing. So this is a case of two proportion test. This is a case of two proportion test. You perform that and check the p-value. If p-value is less than 0.05, what does it mean? Your solution is validated. Isn't it? Your solution is validated, isn't it? P-value less than 0.05 means you have to reject the null. So what is your null in this case? There is no difference in the rejection rate. That is your null. And that is getting rejected. That means there is a difference in the rejection rate.
So there is an improvement.
That means there is an improvement. All that we want is a p-value of less than 0.05 while comparing the proportion. So solution can be validated again by performing the relevant hypothesis testing. Once you learn hypothesis testing, wherever validation is required, you can do that. You will be able to publish your findings in high quality journals also. They will accept it. Right? You have data, you are showing p-value and everything, and then it's good enough to publish your findings. And another normally people also validate solutions by performing FMEA. By performing FMEA. Because what is FMEA? Failure mode and effect analysis. Failure mode and effect analysis. If you make changes in any process, what is the guarantee that the risk levels remain same or no risk level should go down? If by making some changes, if the risk level goes high, you know what will happen? Some other brand new problems will also start populating. Yes or no? So that should not be the case. So when you actually make changes in any process, you must re-evaluate the risk level by performing FMEA. What was the original risk level in the form of RPN? And what is the current risk level? Again, in terms of RPN. So what is RPN? What is RPN?
Risk priority number.
Very good. Risk priority number. It is a product. It is a product of three index. Product of three ranking. Priority, severity ranking, or severity rating, occurrence rating, and detection rating. Severity, occurrence, detection. Based on the severity of the problem, or based on the severity of a failure mode, we call it. Based on the severity of a failure mode, we assign a rank of 1 to 10. If I give a rank of 10, it simply means the problem is high severe problem. Customer gets frustrated if such failure happens. Customer gets frustrated if such failure happens. Say, for example, while flying in an aircraft, the pilot is making an announcement that there is an engine failure. All of you have to jump out of the plane. Now it's life threat. Very hazardous, and you haven't expected, and there were no clue about the problem happening, but we are actually facing. So the problems happens in this manner. It should be given a rating of 10. Please note, one thing is the scenario that decides the rating, but customer has the power to give any rating to any kind of failure mode. Do you understand what I'm telling? If your customer says a particular failure is high severe problem, high severe failure, then you have to give it a score of 10. Yes or no? Suppose, what do I say? Suppose if you people are let's say you are not you are not able to clear the exam which we are going to conduct. You have done your best, you have put all your efforts, but still the exam is designed in a tougher way that you are not able to clear it. Now tell me how severe is the situation. What will be the rating you give? Will you accept it? Or will you really worry about it? You will worry about it, isn't it? On a scale of 1 to 10. On a scale of 1 to 10, how severe is the problem?
10.
How severe is the failure? If we
10.
say you're not going to get the certificate, how severe is the
10, that means
you will get frustrated, isn't it? So we have to give it a score of 10, rating of 10 there. Suppose if we are not able to cover all the topics on time, we are asking all of you to come for one more day. That is also a failure. How severe this failure is.
6 or 7.
6,
It's
7.
You want to give it 7, right? Okay. Then for what kind of failure you will give 1 so that we can freely handle those failures? I want to know.
Maybe that time, whatever getting extended, that for
Yeah.
that we can give 1.
Okay. Taking
Instead
extra
of
5 minutes, 10 minutes every day. So you can take it lightly. Though it's a failure, you all will not mind, we delaying you by 5-10 minutes. That's what we have been doing every day, isn't it?
Correct.
So those kind of
Correct.
failures are less severe failures. So here, how am I getting this 1, 2, 3, 4, and 10? Just by understanding my customer perception. If you are confused, just straight away ask your customer. That's all. That's the best way. The books are there, literature are there, standards are there, rating table is there. But if you go exactly, you will become a mad. And then your customers will also struggle. So instead of that, read all that literature and everything. Finally, and your customer, is the king. You are doing everything to ensure the customer satisfaction. So ask him directly. If he says this is a high severe problem, then it should be given a rating of 10. If he says certain problem, okay, it's acceptable, then it can be 1. In this manner, we have to prioritize. If there are 100 failure modes, for every failure mode, you must give a severity rating. This is the job of the FMEA team. Initially, performing FMEA may be, very tedious. You have to create a table. You have to create a table and make it available. And there has to be a table for every product and then for every possible failure mode. Every possible failure mode, it should be written and table has to be created. And then whoever is performing FMEA at any future point of time, they will be referring to the table. Whatever is decided, that rating can be put. All of you understand how to do it? So this is how severity must be divided. Prepared. And similarly, occurrence rating. What is the guideline for occurrence? When will you give occurrence rating of 10? 10 means the worst is happening. 1 means okay, not very problematic. So when will you give occurrence rating of 10? Tell me. Any idea? If occurrence, yes, ma'am, go ahead.
Yeah, it happens frequently every time.
Very good. If it happens so frequently, that's the time you should give occurrence rating of 10. But what is the what do you call the level? What is the numerical value that we have to declare? If the probability of occurrence is more than 50%, if the probability of occurrence of a failure is more than 50%, then you have to give a rating of 10. You understand? Let's say there is a problem in the paint shop. Color mismatching happens. And 100 cars are painted. How many times mismatches happen? If 65 times mismatch happen, now what will be the occurrence rating you should give
10.
now?
10.
10 out of 10 you should give because this is more than 50%. When can you give an occurrence rating of just 1? When the occurrence of failure is very, very rare. Very, very rare. You have painted so far 10,000 cars. Hardly 1 or 2 have, raised a complaint about paint mismatch. That's the time you should give a rating of 1. And in terms of CPCPK, it should be more than 1.67. In terms of CPCPK, it should be more than 1.67. The failure rate is close to 0. Very, very rare. All of you understand? When the occurrence rating becomes 10, when the same occurrence rating becomes 1. Now the third rating, deduction rating. If your system and your process can detect a failure before something can go wrong, deductibility is better. If deductibility is certain, you can give a deduction rating of 1. If your system cannot detect the failure before happening. Always it detects the failure after the failure has happened. That means detectability is uncertain. Your system cannot detect a failure. In those scenarios, you must give a rating of 10. What I have explained right now, when to give 10, when to give 1, the guideline. But in your product, what are the failure modes? You only have to write down. Don't expect me to tell everything, right? For your product, your service, what are the failure mode? Just think about what are you doing for your customer. I am just, I am a bank, what to say, officer. My job is to open the bank accounts for all my clients. Anybody comes to my bank, my job is to open the bank account. Now, what are the failure modes possible here?
Entering the KYC data wrongly.
Yeah, the customer name is fed wrongly. And then there is an abnormal delay in the opening of the account. These are all you have to list down everything. And then you have to, work on each and every failure mode and bring everything under control. And the industry practice is RPN should always be less than 100. And some companies, even accept 120. RPN should always be less than 100. Whenever it is found to be more than 100, an action is required. That can be taken up as a FMEA project, and then, some kind of improvement will be made and RPN can be brought below 100. All of you, do you understand, even though I explain, orally how the FMEA will happen? First of all, you should list down the failure mode. Then you have to calculate the RPN for that, severity rating for that, occurrence rating for that, detection rating for that, and then total RPN. And then next column, you have to write what will be the effect of the failure. If the failure happens, yes, what will be the effect? Customer dissatisfaction and so many things will happen. And then what is the current control you have right now? To prevent that kind of failure, what is the current control you have? Now, paint mismatch. What is the current control I have? My paint shop manager has to approve before applying the paint. He has to go and check. This is the current control. But despite having the current control mechanism, still still failures are happening. That means an improvement is required. So what is the corrective action you suggest? Don't just believe the signature of the shop floor or the paint shop manager. Bring some other additional check. What can be done additional check? Maybe color selection can be if it is done manually, you can bring a computerized color selection, isn't it? And then approval process can also be modified. So these are the corrective action. And then who is responsible for implementing this corrective action? That should also be written. And then once all the corrective action is taken, you have to recalculate the RPN. Allow a considerable period of time again. Let's say again, for 30, 60 days, you wait. Now what? Then look at recalculate the occurrence rate during the 60 days period. You understand what I'm telling? Occurrence rate and again the detectability and all that. So recalculate the RPN. If the RPN is found to be below 100, then you should be happy about it. Clear, all of you? So this is what typically will happen in the improve phase. So I now would like to show you my slides. Because if I go with the slides, I don't think I will leave all of you by 10 or 10:15. So I have explained everything, and now just to ensure you get the feel of seeing my slides, I will show the slides now, right?
So yesterday, one thing we could not able to discuss, that's actually 6 thinking heads. So
Yeah, that will be discussed next week. That will be discussed next week.
yeah, okay.
So improve
Thanks, sir.
phase.
Thanks.
Improve phase. These are the kind of questions you can expect in the toll gate review. Please read the material and try to understand. But definitely you will be able to answer because we talked about everything. See here, we talked about piloting, right? And this is your question, right? No. Yeah. And then these are the steps. See here, look at your steps. Generate the solution, evaluate the solution, and then select the best one. If needed, optimize it, and then pilot it. And again, go for the full scale implementation, then validate. And finally, the solution is implemented. That is the outcome of the improve phase. And these are the tools. I think we talked about all of these things: benchmarking, creative thinking, nominal group technique, multi-voting, pilot plan, full-scale implementation, FMEA, and DOE and simulation if needed. See, DOE can go in analysis also, or sometimes, it will be part of your improve also, right? So that's how it is. And then the benchmarking, creative thinking, the very simple thing, some stuff to read. So creative thinking means there will be questioning happening for every idea, and experts can be invited. And benchmarking is the process of measuring your products, your service, your process against those of the organization known to be better in one or more aspect, right? Need not be a leader. It should be better than you. And you can also read articles about the companies receiving Best Plant Award, companies receiving Malcolm Baldrige Award, Quality Cup Award, Deming Prize, Quality Management Award. If you actually visit the companies who received these kind of awards, will there be some learnings? Lot of learnings, isn't it? So they are also forms of benchmarking only, right? And multi-voting, you know that. And nominal group technique, you know that. What is nominal group technique? You divide your people into groups and allow them to discuss privately. Sometimes operators should be, allowed to discuss separately. Managers allowed to discuss separately. Top line managers allowed to discuss separately. And the discussion can be, fruitful. And piloting and implementing the solution. Why piloting? Why should we do pilot? If the solution is costlier, you must do piloting. Yes or no? If the solution is irreversible, then also you should do pilot. Right? So certain decisions, cannot be reversed. So in all those scenarios, it is better to do a pilot study. And the implementation approach, what is written here is for the project managers, not for the Six Sigma bells. See here, sequenced approach, parallel approach, phased approach, flat approach. What is this actually, talking is, when you have to implement multiple solutions, how will you implement? You may follow a sequenced approach. Sequence means you go in a proper order, right? After finishing number one, you start number two. Parallel approach means 1, 2, 3, 4, 5 happening parallelly. Phased means one is reaching a milestone, then two will start. Now one is also continuing, two will also be continuing. As the two reaches a particular milestone, it will trigger three. This is known as phased approach. Flat approach. Implement everything in one go. You have that much resource. But whose job it is? Project manager. You as a Six Sigma belt, how many solutions you will be implementing? One solution, right? So you don't have to think much here. You try to implement your solution in a diplomatic way. And then full-scale implementation plan should include all of this. I talked about it. Proper communication, training plan, implementation schedule, and FMEA assessment, and then cost-benefit analysis. All of them are part of your implementation plan. And then improvement validation. You can validate your solution also by performing hypothesis testing or recalculating CP/CPK, recalculating sigma level, recalculating the RPN rating. All that can happen. That's all. This is about your the improve phase. And let me show the FMEA slides also. So severity occurrence reduction rating, RPN method I talked about, and there is one more point you need to understand, which is action priority. That you can this is the action priority table is brought in to avoid the to avoid the complication in prioritizing the projects when the rating coincides. If the RPN is coinciding with another failure mode, then which failure mode should be prioritized? And sometimes we all know that the high severe problem should be given the highest priority. If severity also there is a clash, then high occurrent where the occurrence is higher, that should be given priority. So, but instead of going in that manner, another table is introduced, which is AP table or action priority table. You can refer that also. And two types of FMEA. One is process FMEA, another one is design FMEA. You all know what is process FMEA and design FMEA. Design FMEA means you perform FMEA at the design stage itself, right? After the design only process comes, isn't it? And if there is a problem with respect to the process, then you will be performing process FMEA. But if you are still in the design stage, then your FMEA will be DFMEA or design FMEA. These are all the terminologies in FMEA. AIG means Automotive Industry Action Group. VDA means Verb under Automobile Industry. So it is this VDA which brought the AP, Action Priority Table, right? So this theory I'm not going to read out, and process FMEA and design FMEA. Severity, occurrence, reduction. Maximum is 10, minimum is 1 for all the three. And when the failure is at its worst, that's the time we go for 10 out of 10, right? And certain failures, maybe failures, but still it will not have a big impact, or a customer can take it lightly. Though it's a failure, but it is almost close to a scenario of no impact. In those cases, we give a rating of 1. So here, this is a standard table. Standard table is only for your knowledge, right? But if you really wanted to take action, you must have your own table. What are the failure modes in my process? I will only know, isn't it? Somebody else cannot write your failure modes. If you are reaching office by two-wheeler, how many ways your arrival to the office can get delayed? Your vehicle can get punctured. You can run out of you can run out of the fuel, or some strike can happen on the road. This way you have to proactively write down, right? And then you have to equip your process. That's how it is. And occurrence rating and deduction rating, these are only for knowledge purpose. Just read once and then think of preparing a one on your own. So failure modes are nothing but the possible ways a system or a process can fail. Right? If there are multiple failure modes, the system is considered a complex system. If failure modes are less, then the system is simple. So now what do you see here in the picture? Withdrawing money from the bank. Can you tell me certain failure modes? What are the failures that can happen while withdrawing money?
Money did not come.
Money did not come. Very good.
But cash is means it has been means debited from your
Your
account.
account is debited without issuing any money.
Not that money.
That is another failure. Sometimes, it says money is not available. Sometimes there is no network. Sometimes the button is not operating. Right? And have you ever received extra money while transacting in an ATM? You put 5,000 rupees, but then it disperses 10,000 rupees. That is a failure, but customer never get frustrated for those kind of failure mode. So those kind of failure modes are prevented, in an excellent manner. You never see the ATM machine dispersing extra cash. So the failures which are completely arrested need not be part of your failure mode analysis. The failures which are actually occurring or expected to occur should only be part of your analysis. Right? Once you are exercising the FMEA, slowly, failure modes will keep moving away. They'll move away. And then only the failure modes which are currently troubling you will be part of your FMEA table. The lesser it is, the better is your process. Right? So that's how it, everything, is a part of your continual improvement journey. Initial stages, there can be 100 failure modes, but after a span of 6 months or 1 year or 2 year, the 100 failure modes can be brought down to just 4 or 5. Things becomes manageable, right? So ATM cash dispersal and then car door painting. These are the failure modes. See, I'm writing only 4 failure modes. There can be 400 modes of failure. But why this company is working on only 4 failure modes? You know the reason. They have mitigated all other failure modes well, and only these 4 need some attention and analysis and improvement. So these are the steps. Identify the failure mode, assign the rating, and then calculate the RPM, then prioritize based on the RPM, then write down about the potential effect of the failure, what is the current control you have, what is the recommended action, and once the solutions are implemented, reconduct the effort. So that is demonstrated here. So this is about action priority. So the action priority is whenever your RPN is same for 2 failure modes, come to this table. Say, for example, you have a failure mode where the severity is 9, occurrence is 6, deduction is 5, right? Now look here, the priority is high, isn't it? For the other failure mode, for which also the same RPN is available, you have to find out the action priority in the same manner. It may turn out to be high one more time, or it can turn out to be medium or low also. If you are able to find a different priority, then prioritization becomes easier. But again, if a clash happens, then you can do both of them one after the other. All right, so that's how it is. And see, this is for the ATM case. I'm not going to read out. Maybe you can go through. And this is for the car door painting. So car door painting, 4 failure modes are there. Let us take just one. Color mismatch. Color mismatch, the severity is written as 10. All of you agree? If your car door is painted with a different color from the car, definitely no, you will start arguing. You will not accept the delivery, isn't it? Because your car color is red, but door color is yellow. You will not accept. So you have to demand the correction immediately. So severity is 10. So, and similarly, the what do you call occurrence? Occurrence is based on the number of failures, right? So it is written as 6 for a particular company, and deductibility is 2. That means they have a fairly good deduction system. You see here. That's why the rating is low. But even then, the score becomes 120. And according to the RPN AP table, you see here it is marked as high. Can you see another failure mode that is also 120, but look at the action priority. Low. Do you understand? Now, which one gets prioritized? The red one.
The one that has higher severity.
Very good. That has higher severity. So that, see, action priority table's purpose is to correctly prioritize if there is a clash. All right. And even if there is no clash, I still recommend you to refer the action priority table and find out which gets high priority, which gets low priority, and then decide. Right? And now the current action recommended, automate the color selection process. And who is responsible? The paint shop manager is made responsible, and he has to purchase the computerized machine, and then he has to calibrate it. And now the revised RPN is 24. And if you look here, severity ranking is reduced to 6. Occurrence ranking is reduced to 4. Deduction ranking is reduced to 1. What do you understand? If occurrence rating is reducing, what does it mean? Number of failures have come down. Yes or no?
Yeah.
Looks logical, possible. Okay, let us accept it. And occurrence rate, occurrence is reduced from 6 to 4. And deduction has reduced from 2 to 1. That means some additional deduction you have created. Maybe some extra signature, extra kind of checking that you have done. Maybe before initiating the painting, the customer is invited to confirm the color. That procedure is added now. So that way the detection is enhanced. How come the severity can come down? Can somebody answer this question? Can severity come down or not?
Yeah. We go.
After implementation of the solution, even after improvement, if the failure mode still exists, severity rating cannot change. You understand? After implementing the improvement idea, whatever solution you implement, if the failure mode still exists, then the severity should be same. Because as long as the failure mode is there, severity will be 10 only. You cannot change. If the severity is changing, please understand the failure mode, the process is completely redesigned. The process is redesigned in a way that the failure mode is eliminated from your process. Then only the severity can come down. And failure mode should also be renamed, isn't it? You cannot have same name for two different failures. So this is wrong in my opinion. So I have revised it. 10 remains 10. 4 and 1 I can accept, but 10 I cannot accept. No, the first one 6 I cannot accept. So what is the revised RPN score? 40. So this is the problem with the what to say, the available examples from the available projects. Right? So these kind of some ignorance always happens while practicing. So one such thing is pointed out here. So I think you people have understood the FMEA. Am I right? We are now done with improve phase.
So just one query. The previous, in the pilot samples, I mean, like in the pilot batch we implement the improve phase.
Pilot?
In the pilot run on the improve phase.
Mm-hmm.
Is there any recommended batch size, sample size or something like that, or like it is depending on the process owner?
In that, the context has to be understood and then you have to do the piloting. And of course, there can be many other constraints, budget, time available. If the solution is, urgently required, you don't have time even to pilot. Company is willing to risk.
Okay.
So many factors. But when you talk about sample size, I think I already spoke about it. Sample size always means subgroup size. Whenever you talk about sample, you have to decide 3 things. First one is the span of sample collection. Do you want to collect the sample for 1 week, 15 days, 1 month? That must be decided. You do all of these things logically. I am sure all of you will be able to decide logically, right?
Yep.
1 month will do, 1 week will do,
1 week will do,
or just 3 days will do. Your company's current condition can answer this. Yes or no?
yes.
You don't have to read any literature. Once the span is fixed, the frequency of sampling. Let's say you decided to take sample for 1 week. Now within 1 week, what will be your frequency of sampling? You can decide to take sample once every shift or once every hour or on alternate days. The more is better, but what is feasible for you?
Okay.
You have to take a decision very logically. Otherwise, you will end up with irrelevant finding, irrelevant conclusion, and no meaningful understanding. So once you are once you are through with span of sample collection and frequency of sample collection, now your job becomes easier. Now comes the question of sample size. Without deciding on these two, don't jump to sample size. It will be very difficult question to handle. So now sample size is nothing but the number of samples you take simultaneously when you pick up the sample. When you go for collecting the sample, how many samples you pick up? It is always from 1 to 25. It is always from 1 to
1 to
25.
25.
And here again, the rule is more is better, and 25 is the bigger sample. Even a sample of 2, 3, 4 can also get you the right, information, provided your span of the sample collection and frequency of sample collections are decided correctly. Even a sample size of 2 or 3 can give a better picture.
Okay.
But if you don't give importance to the span and the frequency, even a sample size of 100 can mislead you. Clear?
Correct. Yeah. Thank you.
Okay, good. So this completes our improve phase. Now what is left out? The
Control
control is
phase.
left out, right?
Control
what?
phase.
So can we have this control phase by spending 1 hour on coming Wednesday? Is that okay to all of you? Right?
So what time, sir?
Because- Yes,
time,
maybe. Yeah, tell me 1 hour only. Wednesdays, 8 p.m. is okay for all of you?
Yes, sir. Okay.
Yes,
So Wednesday, we will be concluding, the control
Yes,
phase.
sir.
That will be the completion of the green belt sessions or session session for training for all the green belt participants. However, the black belts are expected to attend the class on coming Saturday, Sunday,
Yeah.
9:30 a.m. to 5 p.m. Please be part of that discussion. It'll be very interesting. And all important tools, whatever you feel like a gap, yes, that will get filled up. And over and above, you will be explained about a lot of additional tools also, which will definitely add up to your understanding. Yes, madam, you have something to ask?
Yeah. So can we have it by 9 to 10, sir?
Oh, evening, yeah. I have no problem. How about others? All of you, do you agree? 9 to 10?
Yeah, because till
Okay, fine.
8:30
9 to 10.
even I have calls, sir.
Till
Okay,
8
9
that we
to 10.
have call.
But beyond 10, it is not possible. 9 to 10.
Yes.
All
9
right.
to 10.
Because today I am also tired, throughout the day session is going on. So I don't think I can do a good job. So we will wind up here. If there are any questions, I would like to answer it. Otherwise, Wednesday 9 p.m. we will be meeting. Any questions you want to ask?
Sure.
Okay,
No, sir.
good night. Good night, all of
Thank you,
you.
sir. Take care,
And
sir.
thank you, sir.
we
Good
will
night.
be sharing some kind of review and rating request in the group. Please take out 1 or 2 minutes and write a honest review and then, rating so that people can understand the kind of experience you had with us, right?
Sure,
So
sir.
that will be of great help to us.
Sure,
Okay,
sir.
thank you.
Thank you.
Thank
Seeing
you,
all of
sir.
you
Thank you,
Wednesday.
sir. Thank you,
Thank you,
sir.
sir.
Thank
Bye
you, sir.
bye. Good night, all.
Good night,
Good
everyone.
night, sir.
Good night, all.